Power Surfacing RE's workflow consists of 4 procedures: importing the reference mesh, quad wrapping it, shrink wrapping the result, and converting to a SOLIDWORKS feature. To import an STL file or an OBJ, go to Tools, Power Surfacing, Import Reference Mesh. Select the file and verify the units on import. With the introduction of Quad Wrap, Power Surfacing RE now provides an automated solution for retopologizing your scanned mesh. The first step is to choose a face size that will define the shape of the mesh's important features. Select Preview to see the results. Size is a percentage of the object's bounding box. At 1%, the faces conform nicely to the contours. Let's accept the Quad Wrap. A quick check for the integrity of the Quad Wrap with Isolate Open Edges tells us we are good to move on to the next step. With Quad Wrap, you captured the essence of the mesh. With Shrink Wrap, you will define the details. Select Shrink Wrap and press Show Preview. At the default 0, the display is switched to Sub D and the vertices are offset back out to the mesh. Turning off Vertex and Edge display provides a good view of the results. Let's accept the Shrink Wrap and convert. A quick check with Section View shows a nice solid. As reference mesh quality and detail varies, so will the optimal values for your settings. Using Distance Display in conjunction with Shrink Wrap provides a means to determining and achieving the accuracy you require. Let's return to the mesh after the 1% Quad Wrap solution and Shrink Wrap. This time let's use a 1.5 solution and finish the accuracy with Shrink Wrap. When you Quad Wrap with an existing Sub D in place, be aware that it clears the prior solution from the undo stack. With Edge and Vertex display turned off, the control mesh facets are clearly visible. By toggling Enable Z buffering, you can see where the faces currently are in relation to the reference mesh. Activating Vertex Display shows that although the vertices are at the surface, the faces are above or below depending on the curvature of the mesh. Now let's look at the Sub D display. This is the version that is used for conversion, so this is where the accuracy must be adjusted. But with Enable Z buffering turned back off, the Sub D faces appear to be on top of the reference mesh. This feature, Mesh Pushback, allows you to see the mesh as you work on it. But it does not reflect accuracy because the subdivision algorithm shrinks the control mesh to achieve the characteristic smooth curvature. If the mesh pushback value is set to 0, you can see how the Sub D has been drawn back from the convex areas of high curvature. Let's set the pushback value back to 50 and turn off the vertices again. Distance Display will help you to determine the amount of deviation. When first activated, it shows the high and low range values. You can manually set the range to see where the areas deviate beyond your chosen values. Let's use 0.5 to minus 0.5. Even at 0 levels of subdivision, you can see how Shrink Wrap offsets the vertices position to compensate for the shrinkage. At 1 extra subdivision level, there are only small areas at the edges of the range. At 2 levels, they are almost all gone. At 3 levels on this mesh, there is very little change. Shrink Wrap attempts to keep large areas of curvature smooth to counteract the roughness often found in the reference mesh. Turning off distance and enabling Z buffering illustrates the point. In this case, 1 level of Shrink Wrap is probably the best choice. With the previous model, we started out with a Quad Wrap of 1.5%. After a Shrink Wrap of 1 level, the conversion was good, but the surface breakdown was a bit heavy. By increasing the face size in the Quad Wrap and increasing the Shrink Wrap levels, you can often get a cleaner surface breakdown. Let's look at a different model. At 0.5%, the mesh is accurately covered. With 0 extra shrink wrap levels, it converts with the dense surface breakdown. The challenge is to use the largest face size that will adequately handle the tightest curvature. Large faces solve quickly, so start big and work down. 10% is not going to work. Let's try 5. %4 is getting better. 3% looks to be a good candidate. The mesh is not perfectly covered, but it may be okay. At 0 levels of shrink wrap, there are a few problem areas. We can turn on Bake into Offset to better visualize the shrink wrap levels. At 3 shrink wrap levels, note that the density looks about the same as the 0.5% quad wrap. Let's switch back to the default for conversion and see what we've got. Now we've got a nice model with a reasonable surface breakdown. As a reminder, let's take a quick look at the earlier version. There's quite a bit of difference.